Okay, let's take a look at the quick check problems to get started. Hopefully when you look at this, you realize that this is a straight angle. So the sum of those two angles, 30 plus x equals 180. Subtract 30 from both sides, and you'll get that x is equal to 50. The next one, when you see this, hopefully again you'll recognize it's a straight angle. If this is 90 degrees, therefore z must also be 90 degrees. Looking at the next picture, you have a perpendicular intersection here. So that means that you have four right angles, and y plus 55 is equal to 90. Subtract 55 from both sides, and you will get that y is equal to 35. Okay, now let's take a look at a little postulate we have here. Sorry, this ended up on 2 pages. Okay, so we're going to draw two intersecting lines, label them as I have, 1, 2, 3, and 4. And then we're going to take a protractor, and you might not have a protractor at home, so you can just write down my measurements. And then we're going to measure that angle. Okay, so I'm measuring here on the inside. I can make that a little larger. There we go. That's much better. Now I'll be able to actually see that. Center the protractor here. So angle 1 is 80 degrees. When I measure angle 1, that is 80 degrees. If I come down and measure angle 2, again, I'm going to put the protractor right at that center and measure angle 2. And I will get that angle 2 should be 80 degrees as well. If I measure angles 3 and 4, I'm going to get that they are each 100 degrees. Now 1 and 2 and 3 and 4 are vertical angles. We know that from chapter 1. We have two intersecting lines with those rays going in opposite directions. So angle 1 and angle 2 are vertical angles. And then angle 3 and angle 4 are also vertical angles. They're a pair, an angle pair, specifically vertical angles. And if we did this experiment in class, I'd ask you to draw a conclusion, but it's pretty obvious to see here that vertical angles are equal. If you look at that, 1 and 2 are equal, and 3 and 4 are equal. So vertical angles are equal. And so the theorem that we have is that vertical angles are congruent. Vertical angles are congruent. We have an example of how we might use this in this find the value of x. When you're told that you have vertical angles, you should immediately mark those congruent so that you know that they are equal to each other. That gives me 4x is equal to 3x plus 35. Subtract 3x from both sides, and you will get that x is equal to 35. And that's all you needed to do for that problem. The next one is a proof. And part of it is on this page, part of it's on the next page, so I'll just draw the picture on the next page. It says if two angles are supplements of the same angle or of congruent angles, then the two angles are congruent. And this, we're actually going to write a proof that proves the congruent supplements theorem. So this proof is going to prove that congruent supplements theorem. So here's my picture. And I will label this 1, 3, and 2. So it's going to prove vertical angles are congruent. That's what we're going to prove algebraically. So I'll start with, so I have to, in order to prove that, I have to prove that angle 1 is congruent to angle 2. And I'm going to do a 2-column proof as we've done in class. Statement and reason. What I'm given is the diagram. So from the diagram, I know that angle 1 plus angle 3 equal, or the measure of angle 1 plus the measure of angle 3 equal 180. And that's from the definition of supplementary angles. I also know the measure of angle 3 plus the measure of angle 2 equal 180. And that's also the definition of supplementary. So from here, I can say that the measure of angle 1 plus the measure of angle 3 is equal to the measure of angle 3 plus the measure of angle 2. And I can use one of two properties. Excuse me, I can use the transitive property of equality, or I can use the substitution property of equality. I could justify both of these as the reasons for making that next statement. Okay, so after that, remember, this is what I'm trying to prove. Angle 1 is congruent to angle 2. I'm going to write that the measure of angle 1 is equal to the measure of angle 2, because I'm going to subtract the measure of angle 3 from both sides. So that would be the subtraction property of equality. And then from there, if I know their measures are equal, I then can say that the angles are congruent by the definition of congruence. And that is the end of my proof. And I can put a little box down there to say that I've ended that proof. Congruent complements theorem would look very similar to this proof. You would just have, instead of equaling 180, they would be equal to 90. Theorem 2-4, all right angles are congruent. So if we look at this picture, if I have two lines that are perpendicular, okay, that's going to create 4 right angles. And all those right angles are 90 degrees, so they're all congruent. That may be something that you'll use in a proof once in a while. Theorem 2-5, if two angles are congruent and supplementary, then they are right angles. So if I had this is angle 1 and this is angle 2, if I say the measure of angle 1 is equal to the measure of angle 2, and I say that the measure of angle 1 plus the measure of angle 2 equals 180, then I would know that they have to be congruent. Okay, and that's actually all for the notes for this lesson. We'll take a look at the practice really quickly, and then that will be the end of the video. If I can scroll down. Okay. We'll just take that off to the side. Okay, so for this practice, it says find the value of the variable and the measure of each angle. So these are vertical angles. That means they are congruent. So 3x is equal to 80 minus x. Add x to both sides. So 4x is equal to 80. X is equal to 20. Therefore, this angle is 60 degrees and this angle is 60 degrees. And that's it for the notes. We will work on the homework problems or the practice problems in the packet tomorrow in class. Have a good evening.